This next approach in Chapter 10.2 to solving quadratic equations is called completing the square. And the first problem I picked was problem number 14, which is x squared minus 6x plus 8 equals 0. The reason I picked that is because we can factor x squared minus 6x plus 8. What we get is x minus 4 times x minus 2 equals 0. Setting each one equal to 0, x minus 2 equals 0, so x equals 2. And then x minus 4 equals 0, x equals 4. So we know our answer should be these two, x equals 2 and x equals 4. Now we're going to take that same problem, x squared minus 6x plus 8 equals 0, and we're going to use the completing the square approach. And how I do that is I remove the 8 by subtracting 8 from both sides. What I end up with then is x squared minus 6x equals negative 8. Now what I want to do is I want to find out what number fits in there to make this a perfect square. And the way I do that is I take the b, in other words, what is the antecedent to the second term? You remember ax squared plus bx plus c. The b is negative 6. What I want to do is take half of that. So that would be 3. Half of negative 6 would be a negative 3. And then I square that. Negative 3 squared then becomes 9. So what I'm going to do now is I'm going to take half of that negative 6, get negative 3, square it and get 9, and I add 9 to both sides. So I get x squared minus 6x plus 9 equals negative 8 plus 9. Now on the left, I have a perfect square, which is x minus 3, the quantity squared, and negative 8 plus 9 gives me 1. When I take the square root of both sides, x minus 3 squared equals the square root of 1. What I will get is x minus 3 equals plus or minus 1. The square root of 1 is 1. So then what I do is I add 3 to both sides, plus 3, and I get x equals 3 plus 1, or I get x equals 3 minus 1, and my answers turn out to be 4 and 2. And so what we did was we completed the square and we got the same answer that we would have gotten had we factored. So now we know that this technique works. But let's take a look at another problem and see how we use this technique. Now for many of the answers, the solution will be plus or minus a radical. And so you won't get clean numbers like what we got with number 14. But I wanted to show you with 14 that this system does work. So if we now take a look at problem number 20, with number 20, what we get is x squared plus 4x minus 4 equals 0. And in completing the square, what we want to do is we want to get rid of that third term by doing the opposite process. This now gives us x squared plus 4x equals 4. Now, when we focus again on this antecedent to the second term, the b, and we take half of that, well, half of 4 is 2, and that squared, 2 is 4. What I want to do is add 4 to both sides. What I get now is x squared plus 4x plus 4 is equal to 8. This is a perfect square, x plus 2, the quantity squared, equals 8. Square root of that equals plus or minus the square root of 8. What we get here is x plus 2 equals plus or minus, but the square root of 8 is equal to the square root of 4 times the square root of 2, which is equal to 2 times the square root of 2. So now what we get is equals plus or minus 2 times the square root of 2. Subtracting 2 from both sides, then we get x equals negative 2 plus or minus the square root, plus or minus 2 times the square root of 2. A lot of 2's in our answer there, but that's it. That's how we did number 20. We want to drop down now and take a look at problem number 28. With 28, what we have is a variable, or we have 2 in front of our x squared variable. So we have to deal with that 2. We have 2x squared plus 10x plus 11 equals 0. Our first step is still to subtract 11 from both sides. So what we get is 2x squared plus 10x equals negative 11. To get rid of the 2 in front of the x squared, what we're going to do is divide each term by 2. What we'll end up with then is x squared plus 5x equals a negative 11 over 2. We'll just leave it in that form for now. What's interesting about this, and the reason I chose this problem, if you take a look at the antecedent to the x variable, you'll see that's a 5. If we take half of 5, we end up with, excuse me, I don't want to do that in black. We end up with 5 over 2. All right? Now, what is 5 over 2 times itself? That is 25 over 4. So what we need to do is add 25 over 4 to both sides. What we get here is x squared plus 5x plus 25 over 4 equals 25 over 4 minus 11 over 2. Now do a little fractional work. 25 over 4 minus 11 over 2 is the same thing as 25 over 4 minus 22 over 4, and that leaves us with 3/4. So on the left side now we have the perfect square, and it happens to be x plus 5 over 2, that quantity squared, equals 3/4. Taking the square root of both sides, x plus 5 over 2, that quantity squared equals square root of 3/4. What we end up with is x plus 5 over 2 equals the square root of 3 over the square root of 4. We're going to put a plus or minus there. But a square root of 3 over the square root of 4 is the same thing as saying the square root of 3 over 2. Now I need to scroll down just a little bit so we have some more space to take a look at this. What we want to do is now we want to subtract 5 over 2 from both sides. What we end up with is x equals negative 5 over 2 plus or minus the square root of 3 over 2. So those two answers then can be combined so that we say x equals negative 5 plus or minus the square root of 3 all over 2. And that's the solution to problem number 28. Takes more steps and takes work with fractions and everything else, but it can be done. And that's the reason I gave you that one as a sample. Now what we want to look at is one last problem, a story problem. This one's rather interesting. The story problem is over on page 707. So I'm going to read that to you. I'm going to have plenty of space to work on this one too, so I'll have to erase what we did with problem number 20. And we're going to look at problem number 40. In 40, it says the demand equation for a certain type of printer is given by the demand equals negative 80p plus 7,000. The supply equation is predicted to be S equals negative p squared plus 220p minus 8,000. They want to find what they call the equilibrium price. At what price will demand and supply be the same? And of course, when they figure that out, then they're going to jack the price up so that the supply, that money, is greater than the demand money. But be that as it may, what we start off with is then our demand. We want that demand to be equal to supply. And demand is represented by minus 80p plus 7,000 equals negative p squared plus 220p minus 8,000. What we want to do, though, is we want to get everything on one side. And since we have a negative sign associated with that p right there, we want to add p squared to both sides. And since we have a positive 220, we're going to subtract 220 from both sides. And since we have a negative 8,000, we're going to add 8,000 to both sides. So what we end up with is p squared minus 80 and 220 is 300 p plus 15,000. That's all equal to 0. But if we're going to complete the square, we have to first eliminate that 15,000. So we have p squared minus 300p equals a negative 15,000. Now what we go ahead and do is we say, what's half of 300? Well, half of that's 150. What if we square 150? What are we going to get? What we're going to get is 22,500. So we have to add that to both sides. I forgot my commas in there. What we get now is p squared minus 300p plus 22,500 equals, what we have now is 7,500. It's nice that that's positive. Let's scroll down a little bit. On the left side now, what we have is p minus 150, that quantity squared, equals 7,500. This then, we take the square root of both sides, and we get p minus 150 equals the square root of 7,500. That turns out to be 86.60, taken out to two places. Just have to plug that in. Now what I'm going to do is I'm going to add 150, I'm sorry, plus or minus that. Add 150 to both sides, plus or minus 86.60. Well, in this particular case, if we add that, we're going to get some fairly high number. But if we take 150 and then we subtract 86.60, what we'll come up with is 0 here, it's going to be 4. It's going to be 3, and 14 minus 8 is 63.40. And so P, their equivalent happens to be $63.40. And there you have it. I think you might have a few story problems on page 707. And hopefully this has been a help in solving those story problems.